So David Thompson has made a career out of first making science and then designing tools that make science. His published work in both the physical and social sciences reflect his love of the scientific method as a way of making sense of the world. David has a PhD in theoretical chemistry from the University of Cambridge and a master's in chemical physics from the University College London. Thank you so much. You're welcome.
Thank you. So I'm going to tell you a story. It actually spans about 10 years, which feels sad and exciting at the same time. So the story is really one of organizational problem solving, crowdsourcing, and serendipity. I do like apologizing at the beginning of talks. I do it because I'm British. I do it for a variety of reasons. It always feels like such a privilege to be able to talk to people. So setting the ground off with an apology feels always appropriate. I will shamelessly abuse the privilege of speaking to you all, though, as an opportunity to bring my problems and outstanding questions. And so I'd really like your thoughts on some of the stuff I'm wrestling with. And so that feels like an appropriate sort of reason to apologize. You know, I offer to tell a nice story in the abstract and then end up rocking up with more questions than answers. Apologies out of the way. I always think that presentations are a great opportunity to see if there isn't a point of commonality amongst us. So what might I have done that may be of help or of interest to you? What might you have worked on that you may maybe think might be of interest to me? And so I always start any presentation with just a couple slides about me and where I'm coming from. So let me move to, my formal training is in the physical sciences, and I have a PhD and did some postdoctoral work in theoretical chemistry. Broadly, this field is the application. It is itself an interdisciplinary field. It's an application of mathematics, computers, and physics to problems of chemical interest. And as a graduate student, that was atoms and molecules. I am glad that when given the question, do computers make mistakes? Joseph described exactly my first 2 years of a PhD: writing code, compiling code, running code. Code does not do what you want it to do. And so that was a nice flashback. But after making it through and getting some sensible answers, I transitioned into the life sciences industry. And then I spent some time working at large pharmaceutical companies. And as part of that journey, I moved away from, you know, what I flippantly call making science to making tools that made science, both for myself and for others. And being a part of a large organization always got me thinking about the patterns I was seeing in terms of how people were brought together to do the work. And seeing this, and to be quite frank, oftentimes it was dysfunctional. Seeing this dysfunction and yet still seeing that we were somehow a viable business, this developed into an interest, and this interest drove me to actually transition away from science and onto the business side of the work. And so I actually spent my final year at a large privately held German pharmaceutical company working on a team engaged in special projects for the organization's leadership. So along this path, I co-founded myself a couple of efforts, one that introduced me to serendipity, and I'll tell you more about that in a bit, and one that related to providing access to STEM professionals. I also spent some time working at a nonprofit. The focus of the nonprofit is on ending homelessness. And it was this period of work and thinking that involved me working with collaborators and making contributions to the making now of rigorous social science. So moving perhaps away from the physical sciences and thinking more about social science. Most recently, I've transitioned back towards the life sciences and actually now work for a software company. Like many of you, I'm sure, none of these activities really ever stop. And so all of these things remain of interest to me. If any of this could be of interest to you, or if I can help in any way, or you just like to chat, just let me know. Now, the work I'm going to describe, it all starts in 2011 over a cup of coffee. I had just moved away from doing science to work on the business side of the life sciences company that I just discussed. And I was attending my first conference, and the focus of the conference was on communications, corporate communications. And I was there as a speaker, and I was going to describe some of the work I had just done on helping my organization adopt and engage with internal social media tools, right? We have this phenomena of consumerization, the fact that some of the best and brightest, shiniest tools now exist on our phones, not on our companies or our organizations provided IT infrastructure. And so there's a tension there. And social media really was sort of new and scary to organizations. And so there was an opportunity to help them bridge this gap. So the conference was in New York. I live in Connecticut, which is just a bit north of New York. And so I got there a little late as my train was running late. But because I am physiologically dependent on caffeine, I had to get a cup of coffee prior to going in and facing the talks. And so in my recollection of this story, this is actually the coffee contraption I was faced with. So I have the time pressure of being in the room and having to get there quickly, the physiological dependence of coffee sort of giving me the shakes, and then this thing sort of being a barrier to me being able to satisfy this. But I don't think it was probably that complicated. I was just being a bit dim. It was probably one of these sort of far simpler coffee pod things. But anyway, after what seemed like a phenomenally long time of me sort of wrestling with this coffee machine, I was tapped on the shoulder by a kindly soul who offered to help. This person was immediately my best friend. And so we had a conversation which went into some really weird places. We quickly started discussing agent-based modeling strategies and stochastic approaches for sampling potential energy landscapes. And it was, you know, pretty interesting sort of physical sciences, physics-based conversation. And it really was not what I was expecting for a communications meeting at all. So this person, as the conversation progresses, is quickly in my mind raised from, you know, kindly helper, sort of very knowledgeable about physics and computing, to an absolute god when they told me their name, and I realized I'd read a book that they'd written on video games. And so the conversation continued, and I'm sort of muttering, I'm not worthy, under my breath every so often. And then this woman told me that she'd recently been working doing some consulting for a new startup in California, and that based on my background and my interests and where I was working, there might be an interesting opportunity there, and that I should chat with the founders. And so by the end of the day, a call was set. The startup is a shop called Kaggle, and these folks are in the business. They are in the business of crowdsourcing. So for the purposes of the presentation this morning, crowdsourcing is the act of an organization engaging a crowd in doing work for them. The crowd is loosely defined, if at all, and it usually engages in the work for a blend of intrinsic and/or extrinsic motivation. Organization in this context is a collection of coordinated individuals that are engaged in actions that contribute to the delivery of a product or services. An early example of crowdsourcing, and this isn't by far the only early example of crowdsourcing, but it's one of my favorites because I'm from Greenwich, is the use by the British government of something called the Longitude Act in the 18th century. And this was put in place by the government at the time to help determine a method to prevent the costly loss of ships at sea. In our more modern usage, when we say crowdsourcing, it's typically a technology that is mediated by the internet or web technologies, right? It's a thing that happens online. Modern crowd work is very varied. So on the left-hand side here, I highlight some sort of simple one-off tasks that can be sourced to a crowd via something like Amazon's Mechanical Turk, or it could be perhaps short point engagements that exist as part of a sustained project-like work, and this could happen via a service like Odesk. And then on the right-hand side, I have sort of the more specialized tasks that are farmed out in the top half of the image to organizations like Kaggle or to Topcoder. And these really represent examples of crowd work that are grounded in the use of computers, coding, and data science to solve. And as such, the crowd-developed solutions are evaluated objectively. There is a measure of performance that a solution is compared against. There are other platforms that exist for complex work, but that have outputs that are evaluated more subjectively, and these include platforms like Tongle and Threadless. And then Innocentive is an interesting platform in the sense that it permits both types of problem. So those with both an objective and a subjective solution evaluation. Now, these platforms, the number and the niches they represent really represent a sort of a market response to something like the Netflix Prize. So the Netflix Prize was announced in 2006, and it was ultimately won in 2009. Netflix provided a bounty of $1 million US to, as they say, substantially improve the accuracy of predictions about how much someone is going to enjoy a movie based on their movie preferences. Anyway, back to my story. So I had it following this conference in my random meeting, my serendipitous meeting, if you will. The CEO and COO of Kaggle were super interested in working with us. And this was partly driven by the fact that they hadn't worked with a pharmaceutical company before. And so this happened in November, and over the holiday break, we were able to develop a very simple competition that went live on March 2012, and it ran for 3 months. The competition was actually super simple. People who wanted to participate were given a spreadsheet, and each row in the spreadsheet consisted of a molecule, but we obstructed the structure of the molecule. The participants didn't know the chemical composition of the molecule. This was obfuscated with just a number. So you had, 1 through, I think there were 900 molecules or something. And then each column was a descriptor. And again, we obfuscated the descriptor from the competitor. They just got a labeled list with these descriptors were 2 through the nth column. And they did not know if it were molecular weight or some abstract graph property, or the number of carbon atoms, for instance. And there were several. It says in the slide here, there are almost 2,000 of those descriptors. The first column, the column labeled 1, contained the endpoint. It contained the biological response. So this was the measured property that was associated to this molecule, and the thing that we wanted people to be able to predict for us. Now, we provided no information in any way that required any benefit to anyone. Having understanding of chemistry, theoretical or otherwise, would provide any benefit at all, right? You don't have to be a chemist to be able to do this. In fact, we'd used an isomorphic property of this problem to turn it into a problem to turn the problem of predicting genotoxicity, which was actually the biological endpoint that we were looking people to predict on. Genotoxicity, for those that are interested, is the unfortunate property that a drug you could take gives you the unfortunate side effect of cancer, which is, of course, a thing that most pharmaceutical companies want to avoid doing, into a pure act of machine learning. Here is a spreadsheet. I want you to predict this column. Go nuts. What was especially cheeky of me in structuring this competition was that I'd actually taken the underlying data set that had been very well known by the theoretical academic chemistry community for a very long time, and which itself had been the source of many previous models having been built. So I took a data set that was very well known by the community, stripped out by the chemistry community, stripped out all chemical information from this, reframed it as just a spreadsheet, and given it to a bunch of data scientists. The log loss measure was our objective function of assessment. And the submissions, the scoring, the leaderboards, the payment, etc., were all handled by the Kaggle platform. If I remember correctly, we had $10,000 for our first prize, $6,000 for the second, and $4,000 for the third. Over the course of 3 months, we had almost 800 people participate. They comprised roughly 700 teams. They'd made almost 9,000 entries, and they engaged in a robust discussion on the Kaggle platform throughout. Couple of interesting observations, and these are all detailed in the manuscript that's been out for a while. The top 100 models that we received were statistically equivalent. The difference between the top 3 models were parts in 10,000. So there were super small differences that split the top 3 winning teams. And I think most importantly, that most of the teams that generated statistically equivalent models in that top 100 rank achieved the same level of predictive performance as the subject matter community within just a handful of weeks on working on this data set. So there's a whole bunch of really interesting implications there for people looking to apply crowds to the work of predictive modeling. There's an interesting story that connects the ultimate winners. The winning team, they picked the second place finalists by 1 part in 10,000. And they themselves had won a couple of other Kaggle competitions prior to winning ours. But it was this fantastically slim win, which was seemingly enough to bolster their confidence to leave their roles as actuaries at the Travelers Insurance Company and to start their own thing. The thing they became is an organization called Data Robot. And this company actually just received $270 million worth of equity funding in November of last year. This is pre-IPO funding that currently values them at about $2.7 billion. So that's kind of an interesting outcome. Now, while ours was indeed the first Kaggle competition to be run by a pharmaceutical company, it was most certainly not the last. In fact, the second such competition, which actually launched just after ours, was created by Merck. Their competition was far more complex than ours in its design and its intent. And it ended up being solved by a deep learning approach. And this was so novel at the time, this was late 2012, that it got the cover of the New York Times. Kaggle itself as a company persists, is now part of Google, having been acquired in 2017. So our experience with crowdsourcing, the literature surrounding it, suggests that it is a very useful tool in the act of organizational problem solving. And it's probably most interesting. We did some work on thinking about, well, when doesn't it work? And so we had an opportunity to participate in submitting a manuscript in 2015 where we outlined some of the considerations around when this isn't going to be a useful tool for you to think about. And most of these considerations relate to the opportunity cost associated with crowdsourcing or the limited fit between the problem and the crowd. So, you know, if you have a bunch of people that can solve this problem for you, maybe you should talk to them without pushing this off to the crowd. When the availability of the crowd of competent solvers is limited, right? If there's 1 or 2 experts in the field, maybe you don't need to engage in a crowd to solve this, right? If you don't have a way of telling whether this is a good solution or not, right? We're very sort of bullish on the role of objectively solved crowdsourcing solutions. This is the 4th bullet point here is really on the sort of contextually dependent. If the suspected cost in time or money of the implementation of the solution is too high, then perhaps it's not a good idea. This was actually the case from what I understand of the Netflix prize. The winning team indeed generated a 10% improvement in the predictive ability to associate movies with people's movie preferences, but the ultimate model that won was never implemented as it was far too complex given their infrastructure to be able to set up. Now, shortly after this work had completed, as part of my day job, I had gotten very interested in trying to rigorously understand the organization I was working at using tools and concepts from the social sciences. I felt that there was an opportunity to employ some graph-based thinking, and I had gone away and formed a collaboration. I found someone to work with, and I'd convinced them that working with me wasn't a bad idea. These were network scientists at Cornell University in New York. I was able to source some email log metadata from colleagues in IT. I was able to source some human capital data from my colleagues in human resources. And because of my prior training, I was able to build a small set of computational tools that generated in an anonymous fashion some curated logs that we could then collectively apply network theory and ultimately rigorous interventions too. And so needless to say, at this point in my career, I was thinking about networks a lot. I was able to sort of connect the network-informed thinking back to some of the ongoing thinking about crowdsourcing. As our Kaggle competition had gotten us a little bit of press, we were contacted by some folks at Topcoder, an organization I previously mentioned that similarly runs objective crowdsourcing activities. And through this random connection with this chap at Topcoder, we had similar interests, and we basically were able to develop this framework. In large organizations, there are lots of things that are happening, and because of something like bounded rationality, not everyone sees what everyone else is working on. And so what we were able to do were take some activities that we felt certain were happening in most large organizations and to arrange them with respect to each other in a way that we felt made crowdsourcing and open innovation a bit more useful. And so we kind of married these two things together. The hypothesis, again, was that there were already a variety of activities occurring and that we could arrange them in this framework such that there was sort of an arbitrary coupling constant that you could use to mediate the interaction between organization and other. And when viewed this way, a weak interaction would be an interaction between the organization and the other through a crowd. A partial interaction would be an interaction where members from different organizations join together into a consortia. And then a strong interaction could be something like a postdoctoral training program or an internship programming. And this may seem true, it may be trivial, but I found this organizational principle actually quite useful because all of these other things were happening anyway. And this provided us a way to talk about them that brought some coherence to these activities and that was actually really quite powerful. So I'm going to pause on the organizational problem solving for a moment and just take a quick tangent. At the end of 2012, following all the Kaggle work, I'd had a really interesting experience that resulted in the creation with a friend and colleague at the time, where we created lunch roulette. I was talking to a participant earlier about me being crap at names and naming things. My original name for the lunch roulette was the diversificationator. So sit with that for a while. As the name suggests, it was a tool for randomly pairing people for lunch. We actually turned this into a product and we sold it to companies, and we did this for many years, actually until the end of last year when we finally shuttered its existence on the web. At its core, lunch roulette is super stupid and it's super silly, but yet on another, it's actually profoundly interesting. And our use of it, our selling of it, our customers' use of it, and the ecosystem of similar solutions that do the same thing. There are currently 6.5 million tools online that do exactly this, randomly pairing people for things. All of this and our participation, it actually served as some super interesting source of things for me to think about. So this was all happening as well.
Just 5 minutes, please. Thank you, Dave.
Yeah, of course. So Greg Lindsay, he's a member of the Serendipity Society, at this time was writing about the rise of technology companies and the use of data-informed approaches to engineer serendipity in the workplace. Greg is just a super kind, super generous person, and he writes very clearly and he writes very openly. And so I found that I was writing my own things on a little space we held connected to Lunch Roulette that were a reaction to his thoughts. And I took pedantic umbrage at his coining of the phrase engineering serendipity, as I felt it was almost too prescriptive. It seemed to be that if you just arrange these things this way, this thing would happen. And so I took some of the ideas I've been exposed to bounded rationality. I took some of my own experiences, and I made a claim that I've garishly color-coded here as to what I thought might be possible, and that I would actually then want to bring to people and say, you know what, this is a thing we could probably do. So no to engineering serendipity, but yes, in my mind, to engineering randomness. I do think that's quite possible. I remain okay with this contribution, right? For a couple of reasons. Firstly, I think it's quite consistent with the more formal scholarship I've subsequently read as part of my exposure to this community, and your focus on rigorous thinking about this. And I think as a synthesis of empirical observations and experience, the fact that it is that consistent, it makes me feel glad. Really more broadly, this definition says something about the environment, right? The green part, and the context, the blue part. And it frames it with a probabilistic bent, right? It is focused on the outcomes, right? So that's enough of my little random lunch roulette tangent. I'm gonna get back, but don't forget this. We're gonna come back to it. In 2019, we were invited again to contribute a review article on open innovation and crowdsourcing. This is the third of 3 papers now. I call this trio of work my Cornetto trilogy, in homage to the British comedians and filmmakers Simon Pegg and Nick Frost. And it was a review. So my colleague and I began looking at the life science adoption of crowdsourcing and open innovation. We did a super simple web search. We took a name of a company, and the name of the company must belong in a list of the top 20 biomedical companies by revenue. We added the phrase open innovation to this. We took a look at the hits that came back, and we kind of clicked through. We came up with a simple 3-point checklist. Do you have a link? Is there a thing on the link for an informed, engaged citizen scientist to do? And a sort of higher barrier of adoption is, do you have a way of describing the work that you are doing in a way that's consistent with our sort of network framework that we had previously articulated? And somewhat surprisingly, 25% of the top 20 biomedical companies actually do. They have a document that's consistent with our network framing, which is kind of interesting. Now it's a review, so we also wanted to make it sexy and appealing. So we spent some time looking to the future, because that's what you do when you want to make things exciting. And so we started thinking about some future trends that we wanted people to consider when thinking about using crowdsourcing and open innovation. And the 4 following bullets were included. I'll mention them quickly because they are interesting. I'll start with the second one first. There's a kind of an interesting uptick in metagaming challenges. Kaggle itself could be framed as a game. It has all the characteristics of a game, and you could do real science on it. And so these metagaming challenges actually take these games that are actually scientific problems and embed them in games. There is a large online community of people playing a game called Eve. As part of Eve, there is an arcade machine, a playable arcade machine in the game itself that you can play, which is actually a classification problem. And the output of the classification problem is science, and the science has been published and tested and is super interesting. So there's a super interesting opportunity of embedding games in places of high foot traffic, right, online. There is a bridging between the physical and the digital, and there are crowdsourcing activities you can participate in where you can make scientific predictions, and they are connected to a laboratory, and the laboratory will actually test the prediction for you. And then we have this opportunity for human in the loop is a part of the artificial intelligence lexicon, and we're suggesting crowd in the loop. Let's just not engage a human, let's engage a crowd. We introduced into this list as well this idea of serendipity in science. There was a huge community of people that were working to formalize serendipity, and we wanted to bring that to our readers as an opportunity for them to engage in. And so ideally, I'd love to be able to give them a list, a simple list, as to, well, if you want to enrich the likelihood of serendipity, these are the things you can do. And if you do that in the context of your organization, magical things are going to happen. I think there's a more important question that I've heard a little bit about today, which is, well, yes, let's say that this set of conditions is possible. How would I know that the likelihood of a serendipitous occurrence had actually been enriched for? And this, of course, leads us to measurement strategies and outcome assessment. I'll make the following perhaps trivial observation, that there's absolutely nothing about how organizations are structured that prohibits serendipitous outcomes or accidental discoveries. So perhaps I'm asking the wrong question. Instead of trying to increase the uptick of these things, maybe I just need to start measuring them anyway. And I was intrigued to see Joseph's use of essentially a logic model previously, where you'd have an input, a process would be embedded in here, and then a series of outputs. And I think perhaps what I'd love to tack on to the end is the measurement of outcomes. This logic model is often used in social entrepreneurship. Borrowing also from social entrepreneurship is this concept of most significant change. Most significant change is an outcomes-driven narrative approach that engages the community within which a thing happened, such that they themselves could potentially surface what is believed to be serendipitous. I know more today about drip irrigation than I've ever done at any point in my life through some of the panels I participated in earlier. And I wonder if this idea of a dripping tap leading to a tree in the desert would have been captured as an outcome through the use of most significant change. Here's what I just told you. Here's how to reach me. Just to finish up quickly, I'm sure I'm a few minutes over my 5 minutes. As a graduate student, at the end of any colloquia we were giving, we were encouraged to share a book or a piece of art or something. And I always cynically assumed that this was because even if the professors had suffered through our work and found it all to be for nothing, they at least had something novel to take away with. And so as an addendum to my apology, here's some stuff you can take away with, even if you've not found any of the other stuff interesting. I've got a non-fiction recommendation, Bring the War Home. Professor Bellows' work on connecting the rise in white power to the US war in Vietnam is just super powerful. It culminates with the Oklahoma bombing in 1995. It's a gripping read. And then on the right-hand side, I have Autumn, which is the first book in Ali Smith's seasonal quartet completed last year was summer. The books run from 2016 to 2020, and they are just super engrossing. So thank you all for your time. I'll shut up now.